So today we'll be simplifying radicals. This will help us out a lot with, we're now entering into a right triangle unit. All right, so background, one piece of background information that we need is we need to have a list of perfect squares. And so here's the list, all the way from 1 squared to 13 squared there. Let's go ahead and define a few things first. First off, a perfect square. A perfect square is any number whose square root is a whole number, or even whose square root is an integer. So, for example, we might say that the square root of 16 is 4. However, the square root of 20 is approximately 4 and I'm making this up, maybe 3. So 20 is not a square root, perfect square. 20 is not a perfect square because when you evaluate it, you get 4.3. And when you evaluate the square root of 16, you get 4. So that's an integer or factors of A. Factors of A are any number that evenly divides A. So for example, 3 and 4 are factors of 12. In fact, so is 2. You could put a 6 in there as well. And the last part is a radical. A radical, another way to say it is square root, at least when we're talking about just squares. And generally speaking, it looks like this. It's the symbol. This symbol right here is my radical. Radical is derived from the Latin word for root. Now, inside, take this number for example, the inside number is called the radicand. So the way that I would read this number right here is I would say radical 13. You could also say the square root of 13, but radical 13 is a little bit faster. And a common mistake many students make is when they see a square root, they often want to approximate it or evaluate. So for example, if I said this, what's the square root of 20? And a lot of people say, oh, they plug that into their calculator. So then they get 4.5. This is what evaluating is, or approximating is this. Simplifying is something completely different. So this is not simplifying. Our answer should not be a decimal. Our answer, when we are simplifying radicals, we are factoring out perfect squares. To factor out perfect squares. To factor out perfect squares. So our answers are going to often look like this. 5 radical 2. So we have a piece that's outside the radical and a piece that's left inside the radical, oftentimes. So let's try radical 48 now, using the factoring method. So again, I start to make a list of any factors, 1 and 48. And this, you don't have to make this list, it can be completely mental. 2 and 24, 3 and 16, 6 and 8, 4 and 12. Notice that I do have perfect squares. 1's a perfect square, 4 is a perfect square, 16's a perfect square. But 16 is the largest. So all this part could be mental. And now, of course, what we break down is the square root of 48 now breaks up so that I have a radical 16 times 3. Then the next step says I'm going to split the 2 so that I have radical 16 and radical 3 as a product. Then I bring down the square root of 16 is 4 and bring down the square root of 3. And there's my answer, 4 radical 3. So let's try this one as using the factor tree. The factor tree here says I can choose any 2 factors for the 48. I don't have to choose the largest perfect square. A most common would be 6 and 8. Some people do 4 and 6. Excuse me, 4 and 12. Now we keep factoring. Notice the 6 can be factored as 2 times 3. The 8 is 2 times 4. And finally, the 4 is 2 times 2. We only look at the bottom row. So in this case, I'm ignoring the 4 now because the 4 has been broken up. So these 2's, the 2, 3, and the 2 here. Now we begin the process of looking for anything that repeats. Here is one pair of 2's, so that 2 comes out. Here is another pair of 2's, so that 2 comes out. And lastly, I have a 3 that is trapped inside. And now I can just multiply those 2's on the outside to get 4, and the radical 3 stays as is. So notice that I get the exact same answer as previously. I got 4 radical 3 here and 4 radical 3 there. Now you're not going to see, at least in our situation, too many of these right now, which is already has a number outside, but you might come across accidentally where you created this mess, which could easily happen. Take, for example, if you were doing this, you don't have to write this down, and you quickly saw that this was 4 times 12, and you pulled the 4 out, the square root of 4 and the square root of 12, and you said, 2 radical 12. Well, it turns out that the 12 still has a perfect square inside of it. So this would not be simplified yet. Yes, you did pull out a perfect square, but you didn't pull out all perfect squares. So if you accidentally create this mess, then this problem here is going to help you remedy that. All right, so let's go ahead and factor this. What we're going to do is take care of this 3 at the very, very end. Take care of the 3 at the end. Now we're going to bring it down still, but I'm going to consider only the 20. So at right now, the 20 can be a 1 and a 20, a 2 and a 10, a 4 and a 5, and quickly we notice that the 4 is the largest perfect square. So how does it break down? Well, I have a 3 radical 20. So the 3 stays outside, and the 20 factors to be 4 times 5. Continuing that journey, now I can split the radicals. So 3 stays there. Radical 4 now times radical 5. Now the 3 comes down. The radical 4 is 2, and the radical 5 stays as is. And now notice here, outside I have 3 times 2. So we have to make sure to multiply them, not add them. Because this whole time it's 3 times this going on here. So in the end, the answer is 6 radical 5. So it's all about multiplying. Now to run through this the same manner, here 2 and 10, 2 and 5. Notice a pair of 2's come out as a 2. This 3 comes down, still outside. This 5 stays in. And we end up with 6 radical 5 also.